All right, are we all feeling, we're feeling okay? It's kind of a, I know it's kind of an academic way to start, but I always personally like to know what in the world is going on, like background information wise, before I dive in too far. And we'll touch on a lot of this again as we come to the section where it's relevant, right? I just want you to have seen it before. So this is going to basically feel like soil science. And that's because it is, and that's because that's really essential for anything you want to do with any plants. So what do trees need? Trees are really variable, so I'm going to give you some broad strokes, right? So this is going to be almost all trees, but like this is a question we got during the break even, is like, yeah, but a longleaf pine has a massive taproot. And you're like, yeah, growing in sand is hard, right? Like, you know, so like what an oak wants is different than what a pine wants. All of these are a little bit different. Something that grows here natively is very different than something that grows in parts of Canada or in Mexico, right? So all of this with a grain of salt, but it's kind of an average for you to think about. Even water really helps. One of the points I heard recently that I thought was so good was that this year we've had slightly less rain than we would have had on average, but it's also a problem because we have compacted clay soils that don't take up rain. And so even water is essential. Anything you can do to help is great. So much of what you'll be doing as a tree keeper is you'll be planting trees that like might never get watered. And so part of that is on the people who are organizing those events, the kind of staff, to really pick things that can handle that sort of adversity. And so that's another thing maybe to keep in mind through this whole section is I'm going to be telling you a best case scenario. The real world is full of compromises. You will learn that. It's fine. Everyone's doing their best. And part of the goal of city tree plantings is basically they overplant. And they also know they're going to go back and they're going to replant whatever dies. Because it's actually way easier to replace 10% than to water 100%, right? Low sunlight exposure for the soil, right? They actually, in general, you want low sunlight exposure for soil. You don't want your soil to ever see sun, but trees especially don't like that. It heats up the roots. Ample space above and below ground. High biological activity in the soil, right? A healthy soil is a living soil. And kind of a moderate organic content in the soil. And so both of these actually go together, and we'll talk about this in a second. Organic matter is great. It is actually what feeds the soil biome. All right, so what does soil do? It provides plants with water, nutrients, actually oxygen as well, and helps anchor them. So basically everything, for the most part, that the plant can't get from the air, which is mostly that carbon it's using to build its body, is coming from the soil. So even though something like 96 or 97% of what builds up a plant comes from the air, that other 3 or 4% is essential, right? And that's coming from the soil. Really excellent soil helps you manage water flow. It breaks down waste and other pollutants. Like, do any of you have septic? Or have you you've been around septic? How does the septic drain field work? It essentially counts on the soil to break down whatever it is you're putting out into the soil, right? Which is crazy when you actually think about it, right? A septic drain field lets that water out of the septic system into a large enough area that the soil can break all down whatever it was you were putting in there, right? And that's phenomenal. Soil is an exceptional purifier and breaker down of basically everything. It just can't be overloaded, right? Breaker down, your official term for today. Provides habitat, and if you have a really good soil, it reduces water and nutrient inputs because it's managing nutrients on its own, it's managing water on its own, it's doing all of these things on its own, right? Without humans, soil was totally fine for a long time, right? We messed it up, and now we're trying to kind of rebuild these systems. Some of the basics of soil that we're going to talk about just quickly are some of the physical properties of soil, chemical properties, and finally moving into the biological properties. It's really helpful to think about all three of these to actually understand what soil is. So, what is soil, right? Soil is actually a combination of a whole bunch of different things. And so this is kind of a zoomed in schematic where you can see you have these big sand grains, but you actually have all this air space as well in between. Plant roots can drown just the way we can. They actually need oxygen, but they also need water because water carries nutrients. So you have to have all this open space, and you actually want all of your little soil particles organized so that they can allow that. So for an ideal soil, what that means is that you have a soil that is made up of basically 50% space and 50% stuff, okay? So the space component of it is that pore space, right? Those channels we saw in the previous picture. You want that to be about half full of air, half full of water in a perfect world. Again, remember, an orchid and a cactus are not the same. So when I say ideal, I mean kind of for the average planting. For the stuff component, you want it to be about 45% mineral. What do I mean mineral? I mean like it's like derived from bedrock, right? Like it is a rock component that has broken down over time and weathering. And you want about 5% organic matter. Compost, broken down leaves, humus, right? The black stuff that when you see soil that's dark, you're like, yes, right? That's what that is. 5% in our climate is actually really hard. We have a very warm, wet climate. Microbes eat the organic matter. In a warm, wet climate, they eat all the time. And so we have to basically constantly be adding organic matter back to our soil because it's not being added in kind of more natural ways, the way it would have if it were a forest. So 5% doesn't sound like a lot, but 5% will be a goal for the rest of your life. Sometimes you hear it, strive for 5. So zooming in on that mineral portion, there are 3 major soil particles. They are sand, silt, and clay. They are basically proportionally that different in size. If you are more of a, I don't know, visual or something learner, you can think of sand like basketballs, silt is almost like a golf ball, and clay then would be like a grain of rice. Not only is it so much smaller, but it's also shaped differently. And so if you can imagine you have a bunch of basketballs, you pour water through, it comes right out, right? If you have that same volume of rice and you pour water through, you're never seeing that water again, right? Like that water is now in that rice. It's going to be very hard to get it out. This is sand. Just take a picture of sand, right? This is clay under a microscope. So you can also think of it, some people find it helpful to think of it as like a cards, basically. It's super, super flat. It has a really different shape. And so what is important there is that you can get to a point where there's no space in between those, right? They can stack up so perfectly and so evenly that if I'm looking for 50% space, but my stuff is perfectly stacked, I'm never going to get that space back there, right? So you know our compacted clay soils where they dry out and they turn just harder than you can possibly imagine, and you can't get them back wet, or they start getting wet and they don't let water back out? It's because of how different that particle is. Classic, right? like we've all seen this. Hopefully this is not your yard, so I'm so sorry. So why does this matter? For clay, water permeation, so can water even get into the soil? And then can the soil hold that water? Kind of the flip side of that, can air get in, right? Because if your soil is so full of water that your plants are drowning, it's because you can't get air in, right? Like you have this thing where water is not moving properly. And then also nutrient supply and availability, and that's the one thing I will say for clay. Clay is amazing for nutrients. Like we have no problem at all with nutrients in our soil because of our clay, to the point where if I had to start with a soil, I would actually start with a clay rather than start with a sand. Like most people around here, we're tired of our clays, and I'm like, oof, give me a clay any day over like what they've got out at the coast, because that's hard. The contrast can be pretty striking. These are both pictures from North Carolina. So clay soils, again, high nutrient holding capacity, high water holding capacity. That's kind of the paradox of clay. It gets dry, it stays dry, it gets wet, it stays wet. Annoyingly so in both directions. Poorly aerated. If you feel it, it feels slippery. Sometimes you can straight up start forming like little animals out of it, you know, like you can build things out of clay. That's why we have a brick industry here. That's why we have a wonderful pottery tradition in North Carolina. Sandy soils, on the other side, they have very low organic matter. They have very low native fertility. What we mean in that, poor nutrients. They have basically no nutrients because the nutrients just pour right through. They don't hold water well, but they are very well aerated. Your plant is not going to drown in a sandy soil. They feel really gritty, you can feel them. The vast majority of what you're dealing with here is going to be clay, but occasionally you actually will run into sandy pockets because we'll talk about this, our soil history, which is wild but true. And that's the only reason I like to talk about sand a little bit, is because every once in a while you'll run into a sandy lawn around here. clay really, really matters is because of the nutrient holding thing. So if we think about a particle of soil, right, sand, silt, or clay, a big one, like sand, nutrients can stick basically to the entire outside of it, right? There's all these little negative charges all over the outside of it, and that's how nutrients stick to it. They have positive charges in the soil, it has negative charges. But surface area, right? If you think about that big basketball, if instead you have that cut in half, or you have that basketball ball you cut into a bunch of grains of rice, your surface area just went massively up, right? And so you have more negative charges everywhere because they're all over all those surfaces, right? So it's a surface area thing. So these plant nutrients that exist in the soil as positively charged things, what they then do is they go and hang out, right? And they stick to it. The fancy soil term for this is cation exchange capacity. It doesn't matter. If someone's always like, what's your CEC? You'd be like, I know what that means. I don't know, but I know what that means. And this is really great because they're bound here. Clay holds them like this, but it doesn't hold them that well. So when water is over here, they can kind of stick to water. They can kind of stick to clay, kind of stick to water. It doesn't really matter. And that's how the plants actually access them. The plants can't pull them off the soil, but they can pull them out of the water. But the soil will hold them. The clay will hold them, kind of in the meantime. If instead you have something like that clay, that big particle we saw previously, right, it can just hold a lot fewer. And that's why clay soils are so excellent at holding nutrients. All right. North Carolina soil history. Why do we have all this clay? Why is this happening, right? So North Carolina is actually fascinating for its soil history because we have so many different soils, and it's because we have so many different origins of our soils. So you have the mountains, right? They were formed between 1.2 billion and 300 million years ago. They actually went up and came down, went up, eroded down, went up, eroded down. They did that for a while, right? And so, as you all know, right, the Appalachians are really old. They used to be a massive, massive, massive mountain range, right? And they've all eroded down to the point like where me being from Indiana, I came from very, very flat land. First time I was ever in Western Virginia doing field work, I was gonna be in the mountains, and I was excited because I was like, it's gonna be mountains. And I got there and I was like, this is not mountains. Like, I was promised mountains, right? But it's because they're eroded, because they're so old. The Piedmont then was added about 300 million years ago. The Piedmont is actually really interesting because parts of this were actually basically a separate mass that crashed into the side of the continent and added the Piedmont. So if you think about like Japan is a volcanic atoll. It's like a crazy volcanic island structure, right? This was something similar that crashed in, but a long time ago. And then finally, right, the coast was deposited, right? So it didn't crash in, but it was like the water used to be much higher, and then the water went down, and it came up and it went down, and it came up and it went down. And every time it left behind sands and other things like that when it was coming back down. And so that's how you get all these sandy soils being deposited over here. Seems kind of wild, but it's true. Geologic time, man, it is. If it's hard to think about a 300-year tree, geologic time is a beast. So specifically in our area, something that's really interesting that we run into is we run into these, you might hear them sometimes referred to as Triassic basins. We are in a Triassic basin. What is that? So we have all this tectonic plate activity. And as those tectonic plates stretched and moved across from each other, they basically opened up these big stretch marks, right? They opened up big stretch marks in the surface of the land, and they were basins, right? They were these deep areas. And then, partially from things like the mountains, but from other sources as well, when the mountains eroded and when other materials moved in with water, clay, boulders, sand, it moved down, right? Because this is lower than the mountains, and it filled those basins back in. And so that's what's really interesting is that in areas where there was a lot of water, and you think of this as like a landslide, you know, and then it's there, it's full, right? Again, we're talking about geologic time. This happened over a very, very long time. But so as these basins get filled, sometimes you get boulders getting dropped because, you know, they were heavy in the solution and they just dropped out. So if you go up to North Durham, like the northern part of the county, most farmers up there have a pile of rocks somewhere if they don't have beautiful rock landscaping around their house. And that's because they took every single one of those boulders out of their field, right? Because it's a clay field full of boulders, right? Because the boulders were carried in that slush, but they just dropped basically wherever they dropped. It's why occasionally you can find pockets of sand, because if there was sand in that movement and it got dropped somewhere, right? That's where the sand is. We have other interesting formations that come up, like our diabase dikes, which are these really strange formations that completely change the pH of the soil around them. You'll see some of that stuff at Penny's Bend, where you have totally different plant communities because there's something really raising the soil pH. So you have a really, really interesting geologic history that kind of happens basically across the whole area. It's also why, like, for example, we have no natural lakes, because it was all clay that was basically allowed to settle out. So our lakes are all reservation, or like reservoirs and that kind of stuff in this area. So this is an article from Our State Magazine in 2012, The Foundation of Everything. If you want like a fascinating, easy read on soil history in North Carolina, I'll include this in the email. This thing's a gem. It's just like a fun, like, this guy's account of learning about soil, but it's fascinating too. But you can really see kind of, right, those different soils we have. You have a little bit of this highly organic soil out at the coast, just because of kind of the marine history out there. But so you have, in the mountains, you have highly organic soil. In the Piedmont, where we are, you have these clay soils, you have your sands, you have some amount of organic up at the end. This is why if someone tells you to plant a native plant, and then they recommend to use something from the mountains here, that's not native here, right? Like plants don't care about state lines, right? Like, that's not native. So the mountains will be cooler and have much higher organic material. Planting a native plant, this area, we call it the Piedmont, it extends up and it extends down. It goes as far up as Delaware, it goes further down as well. If I was gonna plant a native plant, I'm looking for a plant from the Piedmont, not from North Carolina, right? Because I know those plants have my soil. One of the interesting things about the soil we have here is that historically it had really good organic matter. So if you go out to, this is out in a river, you see these beautiful old forests. We had a lot of that here. We had a lot of prairie here. We had thick organic matter. It was really good. It supported all of these trees. It supported a lot of life. But you guys know the thing about the rainforests, right? Where rainforests exist because they exist. Actually, all of the organic matter, all of the growth, all of the vitality of a rainforest is in the plants. And when you remove the plants, the soil is so poor it cannot support them anymore. They have to be there. It's, you know, kind of like paradox. They have to be there to be there. Same thing with ours. When the trees were removed for farming, agriculture, tobacco, and those soils were used and used and used, all the organic matter was basically used up. It was lost. The soils were stripped. And now all of a sudden you're on a much lower level. You're on clay or you're on sand. And these people were not trying to do a bad thing. They thought this was good practice at the time, and they were also part of a system that encouraged basically for them to take what they could this year, because who knows what's going to happen next year. This is what most of us are dealing with, right? Whether it was 10 years ago or 100 years ago, if this happened to your soil, that's rough, right? And so what happens here is that the developers, organic matter is hard. It wiggles, it moves, it does all these kind of strange things. You don't want to build on that. You want to build on clay. Even then, like, build on clay long enough and your foundation's going to crack. But it works, right? And it's better than organic matter. So they take all the topsoil off so they can build their buildings, because otherwise it would be way worse. Like, the buildings would not work. They take the trees out, because if you mess up all around a tree, the tree's going to die anyway. So why not just take it out? It's all these reasons that make sense on paper, but we're still left with this as our planting site, and then they throw sod down and they're like, done. But what you've done when you do that is that this organic matter, this topsoil, this is where the microbes live. Microbes can't live in this clay. That's not what they do. And the microbes are what make your nutrients available. The microbes are what drive the entire system. They make everything available. And so then basically what you're doing is you're trying to grow in a layer that has nothing that will support nutrient availability. None of your microbes. So we gotta add organic matter back. We gotta get this topsoil layer back, and we can. So we're left with a typical Piedmont soil, which is 16% pore space. How much pore space did we want?
Do you mind if I ask a quick question
Yeah.
about the
and it might even be a little bit further, there are actually calculations you can do for exclusion zones, and they can do that, and it might. But you've also so massively changed everything happening around it that it might not. I mean, I would always try it, but I also would not be heartbroken if it didn't work, because it's like you've changed the water flow around it, you've changed everything else around it too, and those big old trees are mature, and sometimes they like kind of want what they want.
So the cities are just expecting them to plant a certain number of new trees? Okay.
Yeah, that's the goal always, is that you would do that, but then you would add topsoil back and you would replant. But it takes time, right? And if the planting guidelines, planting regulations are not good. So yeah. So 16, we wanted 50, right? 82% mineral, which again, we wanted 45. That's compaction, right? You filled your pore space with minerals, just squished it all down. And about 2% organic matter. So we have highly compacted soils that are generally acidic because of our soil history, and you have little organic matter. So why do we keep going on about organic matter? It feeds the microbes. No, you're good. It feeds the microbes, but the other really interesting thing it does is it helps the soil form better. So we've been talking about soil particle sizes, but remember, all those particles have to come together somehow, and that's what we call soil structure, right? If you're gonna build a house of cards, it actually matters how you stack your cards, right? Like, that's very important. So soil structure, this is a really good soil structure. If you go out into a really healthy, nice soil and you dig up a thing like this, it like sticks together, right? Like it has its own structure, it holds, sometimes it can look crumbly, it can look any number of different things. So more organic matter means you have a better structure, and because it's what happens is that the organic matter is actually even smaller than the clay. And so when the clay wants to do this, the organic matter gets right in between and does this. And it feeds the microbes and it does all sorts of other things, so it spaces everything out. The crazy thing is that if you have a clay and you add organic matter, it helps it basically handle water better, so it doesn't become so saturated, it increases pore space. And if you have a sand and you add organic matter, it decreases pore space, which is good because it was way too big, and it holds nutrients. So in all cases, consider adding organic matter, because it actually works for all of the different soil types. So when you have a better structure, you have less compaction, you've spaced out those clay particles, you have better water infiltration, the water can now get in better water movement, and improved nutrient availability even beyond what you already got with clay. Because organic matter is even smaller. Remember, surface area matters. Greater surface area, even more nutrient holding. Once you have that organic soil matter, basically more critters will show up. You do not ever need to go buy a bag of mycorrhiza, even though people will try to sell it to you. You do not need to buy worms. You do not need to buy anything. If your environment is not good enough that they want to be there, they're going to leave. And if your environment is good enough that they want to be there, they will come, right? So add the organic matter and they will show up. As they show up, they break down nutrients, they make them more available to the plants. Everything kind of crawls through the soil, opening up pore space, right? Roots go into the soil, they open up, as they decay, they open up pore space. All of these things happen, right? We want as much diversity in our soil as humanly possible, or as naturally possible, right? So we want as many different critters, we want different types of roots. Think about how when you dig up different plants, some of them have fibrous roots, and some of them have tap roots, and some of them have big, thick roots like carrots, and right, all these different things. All those different root shapes open up different types of soil spaces, and it creates a complex food web. The reason we get so many different pests is because there's a blank slate and the pest can move in uncontested. If instead you have a basically all-out party happening already, even if the pest shows up, his predator might already be at the party, right? So the more diversity you have in your system, the better it can kind of hold itself. The roots are actually really fascinating too, because the roots, remember, give off sugars, like that's how they're feeding their mycorrhizal friends, but they're also just giving off sugars in general. They make so much sugar they don't know what to do with it. That sugar feeds the microbes. Having living roots in the soil at all times is one of the best things you can possibly do, right? So you have roots coming, you have spores, you have fungus, all of that, and those living roots give off the sugar that drive the system. So they make soil even healthier.
What was that? You want roots?
Living roots all the time. So if I have soil My best case scenario is living roots all the time. My second best case scenario is covered with mulch, right? Imagine it, like organisms live in the dark, right? They live in the soil. They don't want sunlight, they don't want all of that kind of stuff. They want to be covered, the soil wants to be protected. But yeah, just imagine that trees and plants are these like wonderful things just kind of giving sugars, sometimes willingly, sometimes unwillingly, to everything around them and feeding all of these systems. Okay, getting the most out of your soil, how do you kind of put this all together? So the majority, like we were saying, of what makes up a plant comes from the air in terms of mass, but those essential nutrients are the thing that kind of make it, right? Like just the same for us, right? We're mostly carbon, but if we didn't have potassium and other things like that to kind of make everything else work, like it doesn't matter how much carbon you put in a pile, it won't turn into a human if you don't have the other things too. Even then it probably won't. So the primary nutrients for plants, these all come from air, but these come from soil: nitrogen, phosphorus, and potassium. Nitrogen is essential for green leafy growth. Phosphorus is essential for what we think of as like roots, fruits, flowers. So not the green leafy growth is how I like to think of it, right? And potassium is kind of overall plant health, right? It's kind of the immune function. These are the three numbers you'll see on a bag of fertilizer right on the front. And it's always in the same order. It's always nitrogen, phosphorus, potassium. We're not going to talk too much about this because half of you already know it, and for the other half, I would love to explain it to you whenever you want. How do you know? You do a soil test. How do you know what your soil nutrients are like? How do you know what your pH is for your soil? We have soil test boxes always available in this office in a blue cabinet that's right outside over there. We also have them inside if you want. Between April and Thanksgiving, we take them over to the North Carolina Department of Agriculture's lab for you. In most cases, I will say it is extremely helpful to know, to test your soil, to know if you have a really strong deficiency. But I would also say if you're working toward building a healthy soil with a lot of organic matter and you're doing all of that all the time and you're picking plants that are suited to your site, sometimes it's nice to do a little bit of fertilizer in the beginning, but a lot of times a healthy soil will be providing a lot of what you need nutrient-wise. Like, I like to think of adding fertilizer as something you do in the meantime as you're building a healthy system. Again, this will be in your notes that you get, linked to all that information, including kind of a write-up on soil testing and kind of a background on it. The NCDA Soil Lab does not test for organic matter in a way that's easily interpreted. So this is really all about kind of the chemistry, the nutrients in your soil. The other number they're going to give you is pH. The reason pH matters so much is because, so this is a great graph. This is like one of my favorite things. It's just made, the moment I saw this, I was like, oh my God, that's why pH matters. So where it's red and thin, it's hard for a plant to access that nutrient. Where it's yellow and a little bit thicker, it can, but it will struggle. And where it's green and thick, the plant can really access that nutrient. Our soils natively are like here-ish, okay? Maybe even a little bit lower. Phosphorus is really hard to get to, potassium is hard to get to, sulfur, calcium, magnesium, these are all hard to get to. That's why like farming in this area is hard. But the thing I will say is that plants that have evolved here are native plants. They evolved with this. And so they have systems in place to kind of get around some of it, right? Like they can kind of compensate for that. And it's a reason to pick a plant that was evolved for a low pH soil. The soil lab is going to give you what you need to get yourself, going to tell you how much lime to add to get your pH up, because typically your pH needs to come up. And this is kind of a sweet spot where it's not perfect, but like you're high enough that most things are yellow at least, right? Getting too much higher is hard, and even then, you know, something's going to be yellow in any band, right? So if you do a soil test, they'll tell you how to get your pH up like that. It's also worth doing a soil test if you're planting for the first time, and especially if you have any construction or anything else like that around you, because I have seen soil tests come back around 8. Because there are things in concrete that basically can drive the pH way up. That'll be leaching into the soil. And also, like I was saying, we have these special soil formations around kind of randomly that drive the pH way up. So I would say if you do a soil test for a tree, because you're not going to be around a lime for the rest of that tree's life, I would take whatever the pH the soil test tells you, and I would be looking for a tree that can do well in the pH I have, more than I would be trying to lime to get to what I want, right? Again, native trees often handle this slightly better, and it's worth looking at, but not all, right? So what do we know? You probably have compacted clay soils with low organic matter. That's probably where you're starting. What should you do? Break it up, maybe. People used to till all the time, don't be tilling, right? Soil microbes want to be in the soil. The reason you till is if you have a really, really, really highly compacted site and you're super worried about it, at the very beginning, when you're first starting that garden, first starting that planting, you can till, just to break it up once. But I would not till beyond that, and even then I would only till if I really knew why I was tilling. Add organic matter. Keep adding organic matter. The rest of your life you're going to be adding organic matter. You're the tree dropping leaves every year in the forest, right? You got to keep adding that organic matter. And pick the right tree for your site, and we'll talk about that. One of the best ways to add organic matter is mulching. People get real down on mulching because they're like, man, I gotta mulch every year because it keeps breaking down. I'm like, yeah, that's the system working, right? Like it's breaking down and it's going into your soil. There's research from NC State showing that basically all that breakdown and moving into your soil really does work, and it really does build that organic profile in your soil. So that's the system working, even though it's annoying. It doesn't really matter. It doesn't really matter what you add, right? Some people add pine bark, some people add hardwood, some people add different sizes, they add shredded leaves, they add compost, whatever, just get something carbon rich on that soil, right? In a pinch, you can always use arborist chips, which you can get for free from Chip Drop. It's a service you sign up for, and when someone's in the area, they have a bunch of chips, they drop them. It's in the name, right? A lot of times they'll drop off like 20 yards, so you've got to be prepared for what's coming for you. But that stuff works really well. If it's aged, which mulches will be, you can mix it in. If it's fresh, like arborist's chips, like from Chip Drop, do not mix it in. Just leave it set on the soil, it will age on the soil, and then it will break down. Don't mix it in though, because it does weird things to the microbes. Like they're not used to being right next to a fresh dead tree, right? Like they're used to being next to an old dead tree, which is aged mulch. Always keep your soil covered. 2 to 3 inch layer of mulch can really, really help. If you have a lot of native plants that you're trying to come from seed, you might want to do slightly less than that because the seeds can't get up through the mulch. But just always keeping your soil covered is essential, whether it's in cover crops, plants, mulch, whatever you might be. You should never see bare soil. Some of the benefits of mulching, it helps suppress annual weeds. 2 to 3 inches is enough to suppress annual weeds, which is why I'm saying if you want your plants to come from seed, do less than that because they don't know the difference, right? It helps keep fruits cool in the summer. It adds organic matter. That's the major benefit. It's better for trees than turf. Bartlett has actually done a fair bit of research showing that having mulched soil instead of grass under trees is much better for root development for those trees. Because if you think about, yes, let me, sorry. If I don't point to you, I will forget that you're raising your hand. If you think about a grass root, it's right in the very top. And where are our most important tree roots? Right in the very top. So they're just in competition. Yeah.
Can you repeat what you were saying about fresh mulch next to the tree or go into?
Yeah, so, okay. So fresh mulch, so things like Chip Drop, arborist chips, that kind of stuff. Basically, microbes are going to decompose that really rapidly, turning it into aged mulch, right? And as they're rapidly decomposing it, they basically use up a lot of nitrogen. They use up so much nitrogen that they start pulling nitrogen from everything around them. And so you can create a condition where you've got a nitrogen poor soil all of a sudden, and it's because the microbes are like having a party on the fresh chips. So if you always leave them at the very top of the soil, not mixed into the soil, that's fine. It doesn't do that. It just creates a tiny little zone where it's like that. Whereas if I were to take those fresh chips and I were to mix them in, I've spread that out everywhere and I've created kind of a broadly nitrogen deficient thing. So it's just to say, fresh chips are fine. There's old guidance that will tell you never ever mulch with fresh. You can. You just can't mix it in. Yeah. And when you're mulching also, as we all know, a mulch volcano, right? Always leave a little bit at the base exposed. So what we call the root flare, it's the area where it literally actually flares out. always leave that exposed. Do not mulch right up to that, because that is what should be exposed to air. And you'll get some kind of weird stuff happening if you mulch right up to that. All right, right tree, right place. We feeling good? Okay. So some of the things you might consider what you're looking for in a tree. What's the goal of the tree? Shade, privacy, beauty. Like, what are you trying to accomplish with that tree, right? If you're trying to get privacy, don't plant a deciduous tree. Plant an evergreen, right? Because otherwise you only have privacy half the year, right? So these are kind of some of those things you think about. What's the site like? What's your available soil, light, water? How big will the tree get? Think both above and below ground, right? Willow, oaks, and hill strips. And some of the other benefits you might get, right? So flowers, bark, fall color, a really huge benefit being like, what does it actually do for the ecosystem, right? So is it something that gives berries? Is it something that gives nuts? Is it something that I know a lot of pollinators like, right? In terms of what is my site like? Space. So this is gonna be things like power lines, right? So when the city does tree plantings now, and if they're planting under power lines, they're always planting species that are not gonna max out like a willow oak, right? They're gonna be these lower growing trees because you have to look up, right? What's this thing gonna run into eventually? Buildings. If you plant right next to the building, not only does it not have room to grow, but a lot of times buildings will even have a little bit of a rain shadow, right? Where maybe it doesn't get quite as wet next to the building. So you wanna get some space away from that. Soil volume. What do I mean by that? Something like this little strip right here, there is not a lot of soil volume there. Where there's no place for the absorbing roots to be there, right? And so this is something where, this was some construction that was happening. I did this talk first during the pandemic and I was going on a lot of walks, so like that's why there's a lot of this. So, you know, first off they scrape the way they're gonna scrape, they're gonna take the organic matter off, because that's how they do this. So this was what they started with. And then they even paved, and then by code, they had to put in some trees. I'm glad code requires trees, I'm not saying that, but I am saying, right, like there might have been a way to think about like how do you actually site all of this more appropriately so those trees have a chance. Because the homeowner comes in to buy one of those and it looks great, and you just think, give it a minute, you know, like, and there are some trees actually that will handle this better than others. Sunlight. So right now, for example, this is north. That if you think about the way the sun comes from the south. So on this side of this building, you will have a pretty long shadow, and you will not have good sunlight next to the building. It's shady. On that side of the building, the south side, you have pavement, and then you have a brick wall, which is the building, and you have direct sun. It will be extremely sunny, and it will be hot because of the pavement and the brick absorbing that heat. The east side is going to be the morning sun. It's the gentlest sun. Just because of some like physics stuff about the globe that I don't entirely understand. The west is the afternoon sun, and it is by far harsher. Morning sun is very gentle, it's very nice. Afternoon sun is very harsh, right? And the plants can tell. So basically, it kind of depends on what does your plant want, right? So if I have a tree that likes kind of gentle sun or light, you know, just mild sun, east would be great. If I have a tree that instead wants really just blazing hot or will tolerate blazing hot, I could think about south, right? And I could think about west. So just think about that. And remember, what we're always trying to do is we're trying to find the combination of tree and site, right? You cannot pick a tree and then be inflexible on site, right? Or pick a site and then be inflexible on tree. You have to work together on those. And remember, sun changes throughout the year. So in the winter, the sun is much lower in the sky, and so it does this arc that's kind of like this. Your shadows are longer, there's less sun during the day. So on the north side of this building where the shadow is, in the winter it might be a very, very long shadow. Might be across the driveway basically, where none of that gets sun. Whereas in the summer, the sun is high in the sky, like this. Your shadows are much shorter, and the sun is longer. Take that into consideration. Also, if you wander outside in the winter to plant your tree, and you think this is a wonderful, bright, sunny spot, yes, perfect. but you are surrounded by deciduous trees. That is not a wonderful, bright, sunny spot. That is a wonderful, bright, sunny spot right now because there are no leaves, right? So just think about kind of all of that together. And it's complicated, but it's worth taking into account. Soil quality, so in terms of compaction or organic matter, right? This is barely even considered a soil. This is like subsoil, right? The organic matter is what elevates it to being a soil. And heat sinks. Heat sinks, this is so important in an urban environment. We're talking about pavement, we're talking about brick, we're talking about stone, we're talking about all of these things that just, you know, there's a reason like a lizard wants to sit on a rock, and it's because it just holds that heat. And it'll hold that heat basically all night even. So these roots will never cool off, and it will always be harsh. Some of the things you can and can't change about a site, I like to think of this as kind of basically a continuum. Water, soil type, heat sinks. Pavement, you're probably not going to change that unless it's your property. Water, again, that tree is going to far outlive you. If it's a dry site and you're trying to plant a wet-loving tree, I love that you're going to water it for the next 70 years, but after that, who's going to, right? You can't change that. Soil pH is very hard to change. That would require liming for the rest of that tree's life. This is an example of a tree that was planted at my parents' house in Indiana. It was given as a tree giveaway, you know, like when I was like, I think an elementary school kid, I like came home with my tree, and it was great. And my dad, who was a forester, was like, that's a terrible tree for this area, but like you are very excited. You know? And so he planted it. And every year, because the soil pH was wrong, even though there was iron, the tree couldn't access the iron, right? Remember that thing we saw? It was like in the skinny red portion. And so every year he went out and he dutifully tapped iron stakes into it. This was like an old school forestry method to fix it, right? And he kept it going. Until it died. And when they cut it down, they sent me the picture of all the iron stakes, basically, that he'd been tapping into this tree for 30 years, right? pH is hard to fix, and it's a problem for plant nutrients.
That's love.
Yeah.
Sweet there.
Sweet, yeah, it says something about him. Very sweet and also very much like, I'm going to do this the right way. Like, okay. Soil biology, you can change this. You can add that organic matter back. And once you have a nice system going, it supports itself better, right? Like it becomes stronger the stronger it is, even though it sounds simplistic, it does. Organic matter, that's even easier, right? Adding organic matter is actually how you fix soil biology, right? If you build it, they will come. And finally, compaction. You can tear through it with the tiller. You can fix that basically once. But again, remember, if it's an area that's a high traffic area, people walking on it all the time, or you know, even equipment on it all the time, it will become compacted again. So I know a little bit about my site. You know, I've taken a look at it, I've kind of considered it, and now I think I have an idea of what my site is. What kind of tree could I have? So we have shrub-like trees. These are the multi-stem, typically less than 15 feet tall. And we'll talk about trees in more detail next time. They often are very wide. A lot of times these are really kind of ornamental plantings. They all have fruits, berries, beautiful fall color, right? There's something about them that typically we really are drawn to kind of ornamentally. It'll be things like witch hazel, which I think has one of the absolute coolest flowers ever, and it comes out in winter and looks like Dr. Seuss. Like, I just love it. You have fringe tree, serviceberry. Serviceberry is really great because it does provide a berry. We have one of those out front. It's this little tree on this side. It's native, and there is a rust fungus that infects it, and so it gets all these weird wiggly orange growths on the berries, which means you can't eat them, but again, they look really cool. I personally think that's fascinating.
The berry tastes amazing though.
The berries are really good. Yeah, it's a bummer, but at least it's a cool looking bummer. Sumac, hazelnut, right? So a lot of times some of the smaller nut trees are like this. That's just pretty. That's beautiful in the fall landscape, right? Small maturing trees, they're typically also in that kind of 15 to 20 foot range, but a lot of times they have maybe one upright stem or just a small number of upright stems. They don't look quite so shrubby. This is going to be things like redbud, dogwood, Japanese maple, not native but beautiful. Redbuds especially, NC State is actually like a real world leader in developing new redbud cultivars, and so there's so many interesting types of redbuds out right now, and a lot of them are So a lot of times, again, these are really beautiful plantings, right? I consider them kind of ornamental. And, yeah.
So, redwoods and dogwoods are not native? I've always heard they're native.
No, they are. They are. I'm saying the Japanese maple.
Uh,
Japanese maple is this tree that like we all have decided to get behind because they're beautiful and fascinating, and they do quite well here. Myself included. Like we're putting together a garden right now. I'm like all native, you know, except for the Japanese maple, because obviously I'm gonna have a Japanese maple, right? But no, redbuds and dogwoods are, and not all dogwoods. You can buy actually a fair number of dogwoods in the trade now that are not native, but we have a very nice native dogwood. A lot of times these small maturing trees require shade. That's something to know too. You put them out in too much sun, they're used to being in the understory. That's why they're small, right? These are guys that are used to growing under other trees. So they like a shadier site a lot of the time. Medium maturing trees, 15 to 60 feet, right? These are, you're starting to get into your bigger guys. Often have really nice rounded forms. 60 feet can be optimistic. Any of these trees, right? Why does bonsai work? Bonsai works because you don't give it enough soil, and so the tree doesn't get bigger. If you give these poor conditions, they'll be smaller. So maples, elms, willows, pawpaw. If you don't know this one, this is a native kind of like tropical fruit, basically, which is really cool. Black locust, river birch. River birch has got, do I have one? Yeah, it's got this beautiful, beautiful bark, right? Exfoliating bark. This is another reason to always know what your tree is and what's normal for that tree, because if you saw that and you did not know it was supposed to be doing that, you'd be very concerned, right? Yeah.
What's the top right?
That's winged elm. That's the next one. So winged elm, if you look up into the branches of it, has these really weird, ugly wings on it. I think they're cool, but like if you saw it, you'd be like, oh God, we're under attack, right? Like it looks like some sort of bizarre fungal growth. But it's just helpful to know always what it should look like. Finally, your large maturing trees, these are the big guys, right? These are the ones that if you have space for this, that is bang for your buck, right? So tulip poplar is really nice. I love tulip poplar because it's got these really cool ancient looking flowers that are bright orange and green and just bizarre. Oaks, American beech, bald cypress we've talked a little bit about. Catalpa is really nice. It's got these crazy like bean pods. These are all just kind of wonderful, wonderful trees if you have space for them. But again, it's worth really knowing what they want, right? Tulip poplar likes a little bit of water. Bald cypress can like a little bit of water, and you're gonna have a hard time planting these where they don't want to be. When you're thinking about natives and non-natives, this is another one that again, life is not black and white. Life is full of gray. So this is the way I kind of think about this. We have what I would consider novel non-natives. These are things that have no close relative here. They're different, right? So it's a shrub, but there's something like Chinese paper bush, beautiful, interesting shrub. There's no close native here, right? And so our critters, our insects, don't know how to eat that because they didn't evolve with anything even similar to it. We have related non-natives, and these actually have a potential ecological value. And so one of the examples is there's a Chinese redbud, and the city has actually planted a number of these. And so the benefit to the Chinese redbud is that it can handle slightly harsher conditions, but because it's closely related to our native redbud, it does get munched on, which being munched on is actually good because it means that someone can survive off of you, right? You are a link in the food chain. And there's a fair bit of research that's come out that these closely related non-natives can have ecological value. And sometimes if you have a site that's really harsh that wouldn't support the native, you're way better off planting the closely related non-native than just watching the native die, right? A native R, this is what we call, it's kind of like a native that's been so highly selected, it's changed form somehow. So if you've ever been to the garden center and you've seen like, there's like a million different echinaceas now, coneflowers, there's a million different coneflowers and they look all sorts of different weird wild ways. Those are what we call native Rs, where coneflower is native, but all the million forms it's turned into are a little bit different, right? They did not evolve in a way that things would recognize them. So that would be in the case of redbud. You'll see a variety of forest pansy, also called merlot, that has purple leaves. That's a native art. You have to be really careful with those. In cases where they have been selected to have purple leaves specifically, or to have flowers that are much more complicated than their wild counterpart, those oftentimes are not as ecologically valuable. Purple is it's an anthocyanin, it's a chemical that the leaves put out to defend themselves against pests. So this thing has basically super amped up defenses in its leaves. And when the flowers change too much, the insects can't get into them the way they're used to, right? So if I'm gonna pick a native R, or kind of a native variety, I'd like to pick something ideally, if I'm worried about ecological value, that the leaves are still the color they always were and the flowers are roughly similar. So here you might instead pick a weeping redbud or a redbud with slightly variegated leaves, but not purple leaves. And then really, there's the native varieties and the true natives. So what do I mean by this? So there is a redbud, for example, Alba, that has white flowers. That's a native variety. They found that out in the forest. Humans didn't do that, right? The tree did that. So, and it's still got green leaves, still doing its thing, right? So that's co-evolved with everything around it. And then there's just our straight up traditional redbud, right? That thing will get eaten by everything, and it's great also because it adds nitrogen to the soil. So just think about where you are on this continuum, because again, if you have a site that's so harsh that won't support a native redbud, it doesn't matter how great of an idea this sounded like, right? This becomes a hypothetical plant in that situation. This becomes like a real answer, that Chinese redbud. So I just wouldn't get dogmatic about it. Some of the resources for finding the right tree. I absolutely cannot recommend highly enough these top two. These are phenomenal. The Plant Toolbox, we'll talk about it, and also the New Hope Audubon Society has great lists. The Plant Toolbox, just check it out. It's awesome. It has all the plants. NC State has been building it for a long time. It's one of the best references basically in the Southeast. There is a find a plant tool at the top where you can tell, like, I have this soil and this water and I want it to do this and I want it to be this big and blah, 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 and I want it to be native, and they shoot you out a list, right? And there's pictures and there's descriptions and there's all sorts of cool stuff. Check this out. This is super cool. It's fun to play around on. If you have a plant you're interested in, you can also just look it up. New Hope Audubon Society puts out really phenomenal lists if you want to prioritize kind of ecological value and supporting insects and birds. Don't get overwhelmed by what's happening on the slide. I'm just going to show you what a list looks like. This is a list that they put out, and I'll send you this link as well, where they have all these different trees, scientific name, how big, what sun, what soil, is it drought tolerant, what else is good about it, is it deer resistant, right? So they gave you these really, really phenomenal lists, and what's so helpful about these is it's number of caterpillars supported. So they're straight up telling you these are the ones that are good for supporting caterpillars, which are the basis of so many of our food chains. The cool thing is they will give you lists, and then they will also give you ranked lists. So if you're like, I got space for one, right? So 488, that's our oaks. Almost 500 species of caterpillar supported, right? And so you can kind of just march down here. And what I like to do, like going for your full plant nerd moment, is you have the New Hope Audubon list, and then you have the Plant Toolbox open, because I can look up and I can be like, what is this black cherry like? Type it into the Plant Toolbox, read all about it, say, oh, that's not quite right for me, and I go to the next one until I find the one that's the right thing for me, but highly ranked for caterpillars, right? Yeah.
Did New Hope specifically do their list for this area, or
Yes.
besides it it's just for this, wonder what the area is?
So New Hope Audubon is basically, I think it's Durham, Chatham, and Orange? Yeah, and so it is for this Piedmont area. But yeah, but it's Piedmont generally, right? So
Greensboro, I was just wondering if
You're
the
good.
list would
yeah, you're still Piedmont, right? Though, so like you're still in the same.
Okay.
This will work for you. Yeah, so this is really fun. And there are places too where they'll say like oaks. And so you might know, okay, well I want to pick an oak, but I don't know, do I want a white oak or red oak, post oak, what do I want? And that's where you might go into the Plant Toolbox and start picking out the specifics of your oak. And this is really important because a lot of times when we think about ecological value, we end up thinking about something like milkweed, which we're like, it supports the monarchs, which is true, and they need our help. But it supports the monarchs. This oak supports about 500 species, right? So I would argue, plant your milkweed, have fun with it, but pick something that will also support hundreds, right? Because that's a real breadth of what you can support. So, thought we would get out early, we didn't. But you guys have any questions?